Om Shri Mahaperivaaya Sharanam. In our past two classes, we have been discussing questions from class 9 NCERT Exemplar book from the chapter Surface Areas and Volumes. Today we will be continuing with the next set of questions. These are short answer questions. Okay, the first one. The surface area of a sphere of radius 5 centimeters is 5 times the area of the curved surface of a cone of radius 4 centimeters. Find the height and the volume of the cone taking pi equal to 22 upon 7. Okay, so how do we do that? Now, we know the surface area of a sphere is 4 pi r square, where r is the radius. So according to the question, this is equal to 4 into pi into r square, 5 into 5 centimeter square. At the same time, the curved surface area of the cone, which is equal to pi rl, where L is the slant height of the cone. So the curved surface area of the cone will be pi into 4, that's the radius, into L centimeter square. Now, according to the statement, the surface area of the sphere is 5 times the area of the curved surface of the cone. So, this 4 pi into 5 square is 5 times pi rl, 5 times pi into 4 into L. So, we get this equation. Now, we can cancel out this pi and this pi, this 5 and this 5, this 4 and this 4. So, we are left with 5 equal to L, or L equal to 5 centimeters. Now, L square is equal to h square plus r square, where h is the height of the cone, right? Now, substituting the values, we have 5 square equals h square plus 4 square, or 5 square minus 4 square gives you h square. Now, either you can do 25 minus 16, which gives you 9, or you know a square minus b square is a plus b into a minus b. So, you can do 5 plus 4 into 5 minus 4 is equal to h square. So, that will also give you 5 plus 4 equals 9. 5 minus 4 equals 1. So, 9 equals h square. So, taking the positive square root, we have 3 is equal to h, or h is equal to 3 centimeters. Now, volume of the cone is 1 upon 3 pi r square h. So, 1 upon 3 into 22 upon 7, that's what they have given, into r square, 4 into 4 into 3. So, 3 gets cancelled. So, we have 22 into 16 upon 7 centimeter cube. That gives you 352 upon 7 centimeter cube, which is equal to 50.29 centimeter cube approximately. So, the height of the cone equals 3 centimeters and the volume of the cone is approximately 50.29 centimeter cube. Next question. The radius of a sphere is increased by 10%. Prove that the volume will be increased by 33.1% approximately. How do we do that? Now, you know volume of a sphere equals 4 upon 3 pi r cube. 10% increase in radius implies r will become r plus 10 upon 100 r, which is equal to r plus 1 upon 10 r, that is equal to 11 upon 10 r. Now, so the volume of the new sphere will be 4 upon 3 pi into 11 upon 10 r the whole cube, correct? So, that will be 4 upon 3 pi into 11 cube is 1331, right? And 10 cube is 1000. So, we get 4 upon 3 pi into 1.331 r cube. Now, so the increase in volume will be 4 upon 3 pi into 1.331 r cube minus 4 upon 3 pi into r cube. So, if you take 4 upon 3 pi r cube as common, within brackets we will get 1.331 minus 1, which comes to 0.331. So, this is the increase in volume. Therefore, the percentage increase in volume will be increase in volume upon the original volume multiplied by 100. That is the percentage increase in volume. So, this 4 upon 3 pi r cube will get cancelled. So, we will be left with 0.331 into 100, which is equal to 33.1. We had to prove that the volume will be increased by 33.1% approximately, and we have got the same thing. So, the volume of the sphere will be increased by 33.1% approximately. That is proved. Let's go to the next question. Next question. Metal spheres, each of radius 2 centimeters, are packed into a rectangular box of internal dimensions 16 centimeters by 8 centimeters by 8 centimeters. When 16 spheres are packed, the box is filled with preservative liquid. Find the volume of this liquid. Give your answer to the nearest integer. Use pi equal to 3.14. Now we have to think. First, we have to find the volume of the metallic sphere using the formula 4/3 pi r cube and then multiply by 16 because 16 such spheres are there. Then we calculate the internal volume of the rectangular box using the formula V is equal to L into B into H. Volume is equal to length into breadth into height. They have given 16 into 8 into 8. Finally, we subtract the volume of the 16 metallic spheres from the volume of the rectangular box to get the volume of the preservative liquid. Okay, so let's begin. We have radius of each metal sphere equals 2 centimeters. Volume of one sphere will be 4/3 pi 2 cube centimeter cube. 2 cube is 8, right? So the volume of one sphere will be 32 pi/3 centimeter cube. So volume of 16 spheres will be 16 into 32 pi/3 centimeter cube. Now keep it like this. Now internal volume of the rectangular box is L into B into H, which is 16 into 8 into 8. Okay. Now the volume of the preservative liquid will be equal to the volume of internal volume of the rectangular box minus the volume of the 16 metal spheres. Okay. Now 16 is common to both and this is 8 into 8 64. This is 32, right? 32 times 2 is 64. I have 16 into 8 into 4 as common and 2 minus pi/3 will come in this bracket. So working that out, we have volume of the liquid to be approximately 488.11 centimeter cube or approximately 488 centimeter cube. Hence, the volume of the preservative liquid when 16 metal spheres are packed in the rectangular box is 488 centimeter cube. Next question. The storage tank is in the form of a cube. When it is full of water, the volume of water is 15.625 meter cube. If the present depth of water is 1.3 meters, then find the volume of the water already used from the tank. So let x be the side length of the storage tank, which is in the form of a cube. So volume of the cube, we know that is equal to x cube, given to be 15.625 meter cube. Taking the positive cube root, we get x equals 2.5 meters. Now, the present depth of water is 1.3 meters. So, the height of the water used will be how much? It was 2.5 meters. Now it is 1.3 meters. So, the height of the water used is 2.5 meters minus 1.3 meters, which is equal to 1.2 meters. Therefore, if this is the height of the water used, the volume of the water used will be, the length and breadth will be the same because only the height is decreasing. So, the volume of water used will be 2.5 into 2.5, the same length and same breadth, but now the depth will be 1.2. So, length into breadth into depth, 2.5 into 2.5 into 1.2, which is 7.5 meter cube. Now, 1 meter cube equals 1000 liters. So, 7.5 when we multiply by 1000, we get 7500 liters. So, the volume of water already used from the tank is 7500 liters. Next question. Find the amount of water displaced by a solid spherical ball of diameter 4.2 centimeters when it is completely immersed in water. Now, diameter of ball is given as 4.2 centimeters. So, radius of the ball will be half of that, which is 2.1 centimeters. Now, we know that the volume of water displaced by a solid spherical ball when it is completely immersed in water will be equal to the volume of the solid spherical ball itself, right? That we know 4 by 3 pi r cube, which gives us 4 upon 3 into 22 upon 7 into 2.1 cube. The reason we are taking 22 upon 7, they have not mentioned whether we have to take 22 upon 7 or 3.14. But since this is 2.1 and we know 3 into 7 is 21. So 21 into 0.1 is 2.1. So for that I have taken 22 upon 7. So 4 upon 3 into 22 upon 7 into 2.1 the whole cube. When we work it out, we get it as 38.808 centimeter cube, which is approximately 38.81 centimeter cube. So the volume of water displaced by a solid spherical ball when it is completely immersed in water is 38.81 centimeter cube approximately. Next question. How many square meters of canvas is required for a conical tent whose height is 3.5 meters and the radius of the base is 12 meters? So we have to think. We have to find out how many square meters of canvas is required for the conical tent. So this requires us to find out the curved surface area of the conical tent because that is where the covering material will be. So in order to find out the curved surface area, we have to first find the slant height. Let's work it out. So height of the conical tent is given to be 3.5 meters. The radius of the base is 12 meters. So the slant height of the cone L will be equal to square root of h square plus r square. Working that out, we get it as 12.5 meters. Now the canvas required will be the curved surface area of the cone, that is the tent. So we can use the formula pi RL. You can also use 22 by 7 for pi or use 3.14. If you use 22 upon 7, substituting the values, we get 471.43 meters square approximately. That is the canvas required for the tent. If we use pi equals 3.14, then we get the curved surface area, that is the canvas required, as 3.14 into 12 into 12.5 meters square. That comes to exactly 471 meters square. In other words, the canvas required for the tent will be approximately 471 meters square. Next question. Two solid spheres made of the same metal have weights 5,920 grams and 740 grams respectively. Determine the radius of the larger sphere if the diameter of the smaller one is 5 centimeters. Now, they are asking us to determine the radius of the larger sphere given the diameter of the smaller one. So, if we have to find the radius, then we have to find the volume first. And how do we find the volume of the sphere? They have given the weight. So we can use the formula density equals mass upon volume. In that case, volume will be equal to mass upon density. Then we'll use the ratio of the bigger volume to the smaller volume to get the required radius. Let's see. So density equals mass upon volume. Therefore, volume equals mass upon density. They have stated that the two spheres are made of the same metal. Same metal means same density. So, if D is the density, then if V1 is the volume of the larger sphere, we have V1 equals mass upon density. That is 5,920 upon D, and V2, volume of the smaller sphere, is 740 upon D. Now, dividing equation 1 by equation 2, we have V1 upon V2 equals 5,920 upon D, the whole divided by 740 upon D. That comes to 5,920 upon 740, and we can cancel the two zeros, we get 592 upon 74. With this, what do we do next? The formula for the volume of the sphere is 4 upon 3 pi r cube. So V1 will be equal to 4 upon 3 pi r1 cube. R1 is the radius of the larger sphere, and V2 will be 4 upon 3 pi r2 cube. R2 being the radius of the smaller one. So V1 upon V2 will be 4 by 3 pi r1 cube upon 4 by 3 pi r2 cube. So 4 by 3 pi gets cancelled and we have r1 upon r2 the whole cube, which equal to 592 upon 74 as already calculated earlier. So with this, what do we get is r1 upon r2 the whole cube equals 592 upon 74. But they have given that the diameter of the smaller one is 5 centimeter, the smaller sphere. So if the diameter is 5 centimeters, the radius will be 5 by 2. So substituting that value, we have r1 cube upon 5 cube by 2 cube, right, which is 125 upon 8 equals 592 upon 74. That gives us 8 r1 cube upon 125 equals 592 upon 74. So transferring 125 and 8 to the other side, we have this. Now you can see 8 times 74 is 592. So this 74 and this 74 will get cancelled. You can see r1 cube equals 125. So r1 will be equal to 5, taking the cube root, 5 centimeters. We are taking the positive value of the cube root. Hence, the radius of the larger sphere is 5 centimeters. Next question. A school provides milk to the students daily in cylindrical glasses of diameter 7 centimeters. If the glass is filled with milk up to an height of 12 centimeters, find how many liters of milk is needed to serve 1,600 students. How do we do this? Now they have given the diameter of the glass as 7 centimeters. So radius of the glass will be 7 upon 2 centimeters. Now the amount of milk, or the volume of milk contained in the cylindrical glass is equal to the volume of the glass, correct? So since this is a cylindrical glass, we know the volume equals pi r square h. Now they have not specifically told us whether to use 22 upon 7 or 3.14 for pi. But we can see since the radius is 7 upon 2, it's better if you use 22 by 7, that value for pi. So using that value, we get the volume as, see, this 7 gets cancelled, 11. So 11 into 7 into 6, that is 11 into 42. That gives you 462 centimeter cube. 462 centimeter cube. So the amount of milk required for 1,600 students will be 1,600 multiplied by 462. That much centimeter cube. So milk required for 1,600 students will be 1,600 into 462 centimeter cube. That comes to 7,39,200 centimeters cube. That is equal to 739.2 liters because 1000 centimeter cube equals 1 liter. So the answer is 739.2 liters of milk is needed to serve 1,600 students. Next question. A cylindrical roller 2.5 meters in length, 1.75 meters in radius, when rolled on a road, was found to cover the area of 5,500 meters square. How many revolutions did it make? Now we have to think. First, we have to determine the area covered in one revolution, which is the curved surface area of the cylinder. Say this is the cylindrical roller. You see the mark over here? Now, for this to complete one full revolution, say it rolls on the road. So when it completes one full revolution, that means it has covered this area, which is nothing but the curved surface area. They have given the length of the cylindrical roller. In this case, the cylindrical roller rolls on the road, right? So the given length is nothing but the height of the cylinder when it is kept upright. So the given length of the cylindrical roller is taken as its height. H equals 2.5 meters. Radius of the roller R equals 1.75 meters. So as discussed earlier, area covered in one revolution will be the curved surface area of the cylindrical roller, which is equal to 2 pi RH, which is equal to 2 into 22 upon 7 into 1.75 into 2.5. So you can see 2 into 22 upon 7 into 1.75 into 2.5. So 7 into 0.25 gives you 1.75. That's why we have chosen pi's value as 22 by 7, which will be very useful in these sort of calculations. Now you can see 2 into 22, 44, 0.25 into 2.5. Now you know 0.25 is 1 upon 4, the fraction 1 upon 4. So 44 into 1 upon 4 gives you 11. 11 into 2.5. That is simple, 27.5 meters square. Now the number of revolutions made by the roller will be equal to the total area covered by the roller divided by the area covered in one revolution. That we know the total area covered is given to be 5500 meters square, and the area covered in one revolution we found out to be 27.5 meters square. So meter square cancel. 5500 divided by 27.5 gives you 200. So the number of revolutions made by the roller is 200. That's the answer. Next question. A small village having a population of 5,000 requires 75 liters of water per head per day. The village has got an overhead tank of measurement 40 meters by 25 meters by 15 meters. For how many days will the water of this tank last? So how do we do that? Total population of the village is 5,000. Water required per head per day is 75 liters. Therefore, total volume of the water required for the village per day will be 5,000 into 75 liters, and that comes to 3,75,000 liters. Now, 1000 liters is 1 meter cube. So, 3,75,000 liters will be 375 meter cube. Now, the total capacity of water in the overhead tank is the volume of the overhead tank. And with the given measurements, we have that volume equal to 40 into 25 into 15 meter cube. Now 40 into 25 is 1000. So 15 into 1000 is 15,000 meter cube. Now the number of days that the water of the tank will last is equal to the total capacity of water in the waterhead tank divided by the total volume of water required for the village per day. That is equal to 15,000 meter cube divided by 375 meter cube. That gives us 40. So, the water of this tank will last for 40 days. That's the answer. Next question. A shopkeeper has one spherical laddu of radius 5 centimeters. With the same amount of material, how many laddus of radius 2.5 centimeters can be made? Now, we have to think. How do we do that? First, we determine the volume of the bigger laddu and smaller laddu using the formula 4 upon 3 pi r cube. Then we divide the volume of the bigger laddu by the volume of the smaller laddu to get the number of smaller laddus. Now, the volume of the bigger laddu equals 4 by 3 pi r1 cube, r1 being the radius of the bigger laddu. So that comes to 4 upon 3 pi into 5 cube centimeter cube. Now the volume of the smaller laddu is 4 upon 3 pi r2 cube, where r2 is the radius of the smaller laddu, and that radius is given to be 2.5 centimeters. So the volume of the smaller laddu will be 4 upon 3 pi 2.5 cube centimeter cube. Now number of laddus of radius 2.5 centimeters that can be made with the same material will be the volume of the bigger laddu divided by the volume of the smaller laddu. If you notice, we didn't do any calculations over here. We just left it as it is, pi into 5 cube. We didn't calculate using pi equals 3.14 or 22 by 7. Now you will see how leaving the calculations for the last minute is very useful. So now when we divide these two, it's easy to cancel out these two, 4 by 3 pi, 4 by 3 pi. Also 5 cube upon 2.5 cube. We didn't work out over there also because it's very easy at the last step. Why? Because 5 cube upon 2.5 cube is nothing but 5 upon 2.5 the whole cube. Now 5 upon 2.5 is 2 because 2.5 times 2 is 5. So 2 cube equals 8. So this is the simplest calculation. So that's why it's always preferable to keep the calculations for the final step, so that all necessary cancellations, striking out common factors, that will be easy. So now we are getting 8. So that means 8 laddus of radius 2.5 centimeters can be made with the same amount of material. So 8 laddus of radius 2.5 centimeters can be prepared with the same amount of material. Next question. A right triangle with sides 6 centimeters, 8 centimeters and 10 centimeters is revolved about the side 8 centimeters. Find the volume and the curved surface area of the solid so formed. Now, when a right triangle with sides 6 centimeter, 8 centimeter and 10 centimeters is revolved about the side 8 centimeters, so it's revolved around this side. So that forms a cone. The solid formed is a cone whose height h is 8 centimeters. The radius r equals 6 centimeters and slant height L equals 10 centimeters. So this is the cone formed when the right triangle, this right triangle is revolved about the side of 8 centimeters. So a radius is 6 centimeters of this cone, slant height is 10 centimeters and height is 8 centimeters. So the volume of the cone will be 1 by 3 pi r square h. When we substitute the values, we get r equals 6, h equals 8. We get the volume approximately as 301.7 centimeters cube. Now, for curved surface area of the cone, we know the curved surface area of the cone is equal to pi rl. If you take 22 upon 7 as pi's value, then we get the approximate value of the curved surface area to be 188.6 centimeters square. If we take pi's value as 3.14, then we get 188.4 centimeters square as the approximate value of the curved surface area. So with this, we have finished the short answer type questions. In our next class, we will be continuing with the long answer type questions. Till then, Om Shri Mahaparivar Sharanam.